Welcome to the notes on solving systems of equations by graphing. So what is a system of equations? Well, a system of equations is just two or more linear equations. Okay, we refer to that as a system. And then what is a solution to a system of equations? Well, any ordered pair, all right, that makes all equations all equations in a system of equations true is called the solution. So here we go. It says determine whether the ordered pair -1, 2 is a solution of the system. Well, remember, an ordered pair has an x and a y value. We are just going to substitute those into each equation in the system of equations. So we've got to do both. So first, the first one, we're going to plug in x. All right, x is -1. All right, we're going to say plus 2 times y. Well, y is 2 from our ordered pair, and then that's going to equal 3. And now we just see, is this equation true? So it's -1. Plus 2 times 2 is plus 4 equals 3. -1 plus 4 is 3. So 3 equals 3. So it works for the first equation. Now we got to try it in the second equation. So we got to substitute those same values. So we're going to say 4 times x. Well, again, x is that -1 minus, all right, minus y. Y is 2. And again, I like to use those parentheses just so we make sure if we have to distribute it all. And then that equals 6. Again, let's make sure it works for both. So 4 times -1 is -4. Minus 2 equals 6. So -4 minus 2 is -6 equals 6. That does not equal. So this is not a solution. So the answer would be no. It works for the first one, but not for the second. It has to work for both. So this is a no. Okay, so I thought we said we were going to do some graphing. Well, here we go. How do we solve by graphing? Well, there's actually 3 possibilities for your solution. The first one, and the one that we're going to see most often, is our solution is the point of intersection right here. All right, that was an ordered pair. Okay, so that's what most of these examples will be. If it's parallel lines, well, what if there is no intersection, like parallel lines? Well, if there's parallel lines, then it's no solution. And how do you know if it's a parallel line? Well, it's going to have the same slope. We learned that earlier. Okay, so if you notice 2 lines have the same slope, not going to be an intersection. Nope, not going to be a solution. And then if it's the same line, the exact same equation, all right, then you'll have, and I'll just write that same equation. Well, then you know they're going to overlap infinite solutions, okay? So those are your 3 possibilities. Let's take a quick look at what those look like. So first one, all right, we're going to graph each equation just like we already know how, and then we're going to find that point of intersection. So y equals x minus 4. I'll do that in blue. All right, well, that's really a 1/1 in front of that x. I'll erase that, okay? So m equals 1/1. So we go to -4. Again, that's where we begin. 1, 2, 3, 4 right here. And then the slope is up 1/1, up 1/1. Okay, and we can go negative this direction. All right, I'll make my line. Now I'll do the second equation. Now this equation, it's not in slope-intercept form. We have to get it in slope-intercept form. So it's -2x to each side. So when I rewrite that, it's going to be y equals -2x, then +5. Remember, that's really -2/1, by the way. So we're going to go up to +5. That's where we begin. 1, 2, 3, 4, 5. Okay? And then our slope is -2. So it's down 2 to the right 1, down 2 to the right 1, down 2, 1, 2 to the right 1, down 2 to the right 1. And you can see these graphs will intersect. Well, where is our solution? It is that point that they intersect, and it's an ordered pair. So what is that point? That point is 1, 2, 3, down 1. So the solution is 3, -1. If I plug that into each equation, they would work for both. So there's one where there's one solution. Now these 2 right here, we can do quick. One will be a no solution, one will be an infinite solution, just so you can see what that looks like. So I'm going to subtract x. So this is going to be y equals -x plus 6. Again, just subtract that x from each side. And then this one right here, I'm going to subtract the 2x minus 2x. So it's going to be 2y equals -2x plus 16. Divide everything by 2. So y equals, all right, that's -x, and then that's +8. Well, you can see right here, they're going to have the same slope, that -1. I know these lines are going to be parallel, so it's going to be no solution. But if you want me to graph that real quick, you go up to 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. All right, -1, down 1, down 1, down 1, over 1. There's my line. And then I would do the same thing for plus 6, down 1 over 1. And you could see that these graphs would never intersect, so that would be a no solution. The next one, it would become the same equation. Again, I subtract 4x, so I get 2y equals negative 4x plus 6. When I divide everything by 2, y is going to equal negative 2x plus 3. It's the exact same equation as this one. It's going to be the same line, so that would be an example of infinite solutions. So there you have it. That is how you're going to solve systems of equations by graphing.